आज के वीडियो में हम लोग डिस्कस करने वाले हैं कंडीशनल प्रोबेबिलिटी के बारे में, राइट। सपोज कोई इवेंट है ई, उसका सैंपल स्पेस एस है और उस इवेंट की प्रोबेबिलिटी होने की संभावना है, राइट। देन प्रोबेबिलिटी ऑफ इवेंट ए given that event E happened. Suppose there is an event A which occurs. A occurs when E has already occurred, right? Then probability of event A given E will be given as probability of A intersection E by probability of E, right? And this can be represented as conditional probability, right? Now suppose I have a question. A pair of dice is tossed, right? A pair of fair dice is tossed and the sum of numbers displayed on the two dices are 6, right? Then find probability of one dice having 2 displayed on their face, right? So sample space will be 6 to the power 2, 36, right? And event in which sum is 6 will be, I am writing the sample space 1, 6, 1, 5, 5, 1, 4, 2 and 2, 4, right, and 3, 3. So probability of this event is number of sample space 5 by 36. Now A is the event in which one dice is 2, right? So one dice is 2 will be this and this, so it will be 2 by total sample space 36. Now probability of this is what? This is A intersection with E, right? We want A intersection with E. So probability of A intersection with E by probability of E will give me probability of A given E, right? So this will be 2 by 36 by 5 by 36, which is 2 by 5, right? Now next question is 3 fair coins are tossed, right? And I have to find probability of all heads in the coin given. First coin is head, right? So sample space will be 2 to the power 3, right? I have 3 coins and each coin can give me tail or head. So I will have sample space of 2 to the power 3, which is 8, and event of first coin having head is first coin having head will be, right, either tail or head, either head or tail, either head, tail, or either head, right? These are the possibilities. So probability of this event will be 4 by 8, right? And all 3 should be head, right? E intersection A, this event is all 3 should be head. So probability of E intersection A will be 1 by 8, and probability of A given E will be thus this by this, so it will be 1 by 4, right? Now next question is 3 fair coins are tossed. Now this time we have to find probability of all heads given at least there should be one head, right? So I will write my event head head, tail, head, tail, head. Basically, at least one head means all the cases where, except one case where all I will get tails, right? So this will be written as H, T, T, right? And then it will be T, H, H, T, H, T, 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 H, and then H, T, H, right? No. How I will do this? I know my sample space is 2 to the power 3, 8, right? So what I will do? Head, 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 right? Then middle head, middle head, middle head, and then last I will be having head. So this will be tail head or tail tail or head tail, right? Then this will be tail head or head tail or tail tail. This will be tail, head, and these are matching, so I will not consider this one. Sorry, this will be tail, tail, head, right? Tail, head, head, and head, tail, head, right? This is the same, so I will not consider this. So overall I have, and this is also matching, so overall I have 7 cases, right? So probability of E will be 7 by 8, and in this B intersection E, all 3 coins should be head, so there is only, right, there should be one more case, head, 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 right? So this will be 1 by 8. Now probability of B given E will be 1 by 7 by 8 and 1 by 8. So probability of B given E will be 1 by 7, right? Next question is, I have pair of fair dice thrown, both faces different, right? Both faces different. Find one, sum 6 and 2. Sum is less than 4. Given 2 faces are different, right? So the event, my event A will be, sum should be 6, having intersection with event E, because sample space, right, E, both different cases will be 30, right? Because in 6 cases all will have same number 1 1 2 2 3 3 4 4 5 5 6 6. So I will subtract inside sample space minus 6 and I will get 30, right? And event A in which the sum is 6 and this intersection with event E, right, these different faces will give me 1 5 5 1 4 2 2 4. I will not consider 3 3, right, because it is about different faces, right? Now probability of A given E will be simply 4 by 36 by 30 by 36. And next question is, sum should be less than equal to 4. So in this case B, sum less than 4, intersection E will be what? 1, 2, 2, 1, right? 3, 1 and 1, 3. So again 4 by 36 by 30 by 36, right? Now I am erasing this one we will move on the next topic. Right. Next topic is a stochastic process. Stochastic process. Right. An experiment that occurs in multiple phases. A finite sequence of experiment, each with a finite number of outcomes, given probabilities, is called a stochastic process. Suppose I have two bags, like bag 1 and bag 2, and bag 1 has two red, 3 white balls. Bag 2 has 5 red, 2 white balls. Right. A bag is randomly chosen. Then a probability of ball will be given as, first there are two bags. So probability of bag 1 will be chosen will be 1 by sample space 1 and 2. Right. And then probability of red from bag 1 will be 2 by 5, because number of balls are 5, in this case 7, so it will be 2 by 5. Number of white balls from bag 1 will be, probability of getting a white ball from bag 1 will be 3 by 5. Similarly here, probability of getting red ball from bag 2 will be 5 by 7, and probability of getting white ball from bag 2 will be 2 by 7. Right. Now, probability of overall getting a red bag will be, a red ball will be 1 by 2, because I have chosen a bag 1, and then this multiply because it is happening at same time. Right. This is not independent event, this is dependent event, so I am using here multiplication. And similarly here 1 by 2 into 3 by 5. These are probability of getting a red ball from bag 1 if bag 1 is taken. Right. Right. Similarly here it will also, this is the probability of getting red ball from bag 2 if bag 2 is chosen, and this will be 1 by 2 into 2 by 7. Right. Now, overall probability of getting a red ball will be this probability, that is half the 2 by 5 plus probability, this probability 1 by 2 into 5 by 7. This is my probability of getting a red ball. Now, we will discuss about multiplication theorem of conditional probability. Multiplicational theorem of conditional probability, that is probability of A, event A given E will be probability of A intersection E by probability of E. Now this I can write probability of event E intersection A. Suppose there is a big event E and A has happened, right? So this I can write it as probability of E, the complete event, and an event which occurred when E occurred, right? So this will be written as A given E, right? Because event A occurred when E has already occurred, right? So Similarly, probability of A1 intersection A2 AN will be given as probability of A1 multiply probability of A2 by A1 multiply probability of A3 by A1 intersection A2 multiply probability of AN divided by A1 intersection A2 intersection AN minus 1. Right. This was multiplication theorem. Now we will discuss about law of total probability. So if A1, A2, A3 and AN are is a partition of sample space S which is mutually exclusive. Mutually exclusive means two events A and B cannot happen at same time, not simultaneously, right? And exhaustive, mutually exhaustive means these all events are from sample space, and when I will add the probability of all these events, it will sum up to 1 because all those events will union of all these events will give me sample space, right? So suppose A1 union A2 union A3 AN is my sample space, and these A's don't overlap, which means these are not mutually these are mutually exclusive, not मतलब these are not जो दो events right overlap करे. I am not remembering the term that is mutually. One second, the term was something. Right, mutually exclusive event, right? So these are all independent of each other, right? Mutually exhaustive means this means mutually exhaustive, and mutually exclusive means these all are independent events, right? Basically this A and B, this does not overlap, and this sum will be give sample space. This is mutually exhaustive, right? Now probability of, suppose B is any event, probability of B will be given as probability of A1 probability of B by A1 plus probability of A2 B by A2 plus probability of AN B by AN, right? This is the law of total probability, right? And now let's solve a question. Suppose there are three machines A, B and C produce 50%, 30% and 20% of items, and defect rates are, defect rate means out of these items how many items will be defective. So defect rates are 3%, 4%, 5% for A, B and C. So what is the probability of getting a defective item, right? So machine, right, A, B, C, I have machines. Probability of getting item from that machine is, that is this. So it will be suppose this sums to 100. There are 100 items. 50 items I get from A, 30 items I get from B and 20 items I get from C. So probability of getting item from machine A will be 50 by 100, which is 0.5. Similarly 30 by 100 0.3, 20 by 100 0.2, right? And then probability of getting defect rate from machine A, 50% item I get, and out of that 50% I get 3% defective, right? So yes, given that item is from that machine, the defect is 0.03, 0.04, 0.05. So probability of getting defective will be these are simultaneous events, right? So I will write probability of getting defective will be probability of machine getting item from that machine, and probability that that item is already defective from that machine will be 0.5 into 0.3 plus 0.3 into 0.04 plus 0.2 into 0.05. This is my answer, right? Now this is all for this video. We will discuss next topic in next video, right?